Example number 53. Evaluate the integral 4x squared plus 7x plus 3 over x plus 3 into x squared plus 9 with respect to x together. Now this one is direct. This one is very direct. So it means this is integration by partial fractions, isn't it? It is integration by partial fractions. So we must resolve this into partial fractions. So we have 4x squared plus 7x plus 3 all over x plus 3 into x squared plus 9, isn't it? Ladies and gentlemen, then look in the denominator. This first factor is a linear factor, isn't it? X plus 3 is a linear factor. So it is going to be a over x plus 3, isn't it? This second factor, x squared plus 9, so that's a quadratic factor. X squared plus 9 is a quadratic factor. So a quadratic factor, it is going to be bx plus c, very good, over x squared plus 9. That is how to resolve a quadratic factor into partial fraction, isn't it? Bx plus c over x squared plus 1. Plus 9, I mean. So what do we do? LCM, isn't it? So what is the LCM? The LCM must be what you have there, isn't it? X plus 3 into x squared plus 9, isn't it? X plus 3 into x squared plus 9. So you go, here we have a in the numerator into x squared plus 9, meaning x plus 3 goes here how many times? X squared plus 9 times, isn't it? Now there are only two factors. When there are only two factors, we can just cross multiply this times this, that times that, isn't it? Are we together? So you can see x plus 3 goes here, x squared plus 9 times. X squared plus 9 times here, you get that, isn't it? Then it is plus, the whole of this is one factor. So it must be in bracket, isn't it? So it is plus bx plus c. Then you check. X squared plus 9 goes here how many times? X plus 3 times, isn't it? So x plus 3 times that, you get x plus 3 times 8, isn't it? So are you seeing? The numerator is the same as the numerator. The denominator is the same as the numerator, isn't it? So you can see your numerator here is 4x squared plus 7x plus 3 over x plus 3 times x squared plus 9. Are we together? So you can see the denominator is the same, isn't it? If the denominator is the same, then the numerator is also the same. Are we together? The numerator is also the same. So it means we are now comparing the numerator, isn't it? So what do we have on the left hand side of the equation? 4x squared plus 7x plus 3. When I say the numerator is the same, meaning the numerator just cancels out. We remain with the numerator to be equal to numerator, isn't it? Is that okay? So you remain with 4x squared plus 7x plus 3 to be equals to what? A into x squared plus 9 plus bx plus c into x plus 3. Are we together? Then we now start solving, isn't it? We start solving. So you let x to be anything to eliminate, isn't it? So start. When x is, what can eliminate x to 0 here? When x is negative 3. See, negative 3 plus 3 will be 0. Are you seeing that? So you can let x to be negative 3 to take it to 0 here. Then 0 will ensure 0 times the whole of this factor will be 0. You don't remain with the 8. Are you seeing? Are you seeing how to choose x? Yes. So when x is negative 3. So negative 3 plus 3 will be 0. 0 times this term, the whole of that will go to 0, isn't it? Then you remain with this term only. Are we together? So when x is negative 3, what do we have here? Negative 3 squared is positive 9 because both negative and 3 are squared, isn't it? So 9 times 4. So it is just 4 into negative 3 squared plus 7 into negative 3 plus 3 is equals to a into negative 3 squared plus 9. Because negative 3 plus 3 is 0. 0 times the whole of this factor, the whole of that will go to 0, isn't it? Are we together? Yes. So from there, what do you have? Negative 3 squared is 9. 9 times 4? 36. 36. 7 times negative 3 minus 21 plus 3 is equals to negative 3 squared is 9. 9 plus 9, 18 times 8, isn't it? So use calculator. 36 minus 21 plus 3, 15. 18. So you have 18 to be equals to 18a, isn't it? So what is the value of a?
1.
A is 1. So this implies a is equals to 1. So you have found the value of a. Having found the value of a, you now want to look for the value of b and c, isn't it?
Yeah.
You now want to look for the value of b and c. So start. When? What can you let x? When x is 0, isn't it? So you can let when x is 0, because as long as we found 1, the rest, even if we remain with the 2, forming a linear equation into 2 variables is easier to solve, isn't it? Isn't it? Yeah, it's easier to deal with. So when you let x to be 0, you'll see you'll be able to eliminate b because we have bx. See, when x is 0, b will disappear. And when b has disappeared, even if you remain with a, where there is a, you are going to put the value of a, isn't it? Because you've already found the value of a. So when x is
0.
Yes, when x is equals to 0, so that b times 0 is 0. b disappears, isn't it? Are we together? So do that. When x is 0, what do we have? Where there is x, put 0. This is our equation we are using. Where there is x, put 0. This is 0, this is 0. You remain with 3, isn't it? Then 0 squared, you remain with 9a, isn't it? 9a, then this is 0, you remain with the c here, isn't it? This first factor, you remain with the c here, is 0 plus 3, you remain with 3, isn't it? So 3 times c, you remain with plus 3c, isn't it? Then you substitute the value of it because you've already found the value of a to be 1. So this implies what is the a? It is 3 into 9 plus 3c, isn't it? Because a is 1. A you've already found to be 1. So taking 9 this side, you get 3 minus 9, isn't it? 3 minus 9 is negative 6 to be equals to 3c, isn't it? So you divide both sides by 3 to get c. Are we together? So we found a. If you divide both sides by 3 to get c, what do you get to be c? Negative 2. You found a and c. See, this method is simpler.
Yes.
After getting a and c, you can now choose x to be anything again to get the value of b. Isn't it? Yeah, so you choose anything, we choose. See, we can even choose 1 now, so that we remain with a, b, and c, and we substitute the value of a and c. Isn't it? So when x is 1, 1 is simpler to use, isn't it? When x is 1, you will have whether it is square root raised to 1 raised to power anything is 1, isn't it? So when x is 1, here we remain with 4 plus 7 plus 3, isn't it? Because x is 1. 4 plus 7 plus 3 is 14 is equals to x is 1. 1 squared is just 1. 1 raised to anything is 1, isn't it? 1 plus 9, 10a, isn't it? 10a, a is 1. Are you seeing that? Then plus bx, x is 1, isn't it? So it is b plus c. Remember c is negative 2. You see, you are substituting what you know. Have you seen that? See, this is bx, x is 1, meaning it is b plus c, but c is what? Negative 2, so it is b plus c, c is negative 2. Unaona? Then you move on there, another bracket, x plus 3, x is 1. 1 plus 3 is? See, x is 1. 1 plus 3 is? See, you substituted all the nodes. Where there is c, you place the value of c negative 2. Where there is a, you place the value of a is 1, isn't it? Where there is x, you put the value of x is 1. So you end up with 14 is equals to? Now, 10 times 1 is just 10, isn't it? 10 coming this side of the equation is 14 minus 10, isn't it? You remain with 4 to be equals to b minus 2 into 4. So you divide both sides by 4. You remain with b minus 2, isn't it? So if you divide both sides by 4, 4 by 4 by 4, you remain with 1 to be equals to b minus 2, isn't it? So this implies what is b? Negative 2 coming this side, 1 plus 2. You get b is 3. See, this is negative 2. Negative 2 can take inside, see, this 1 plus 2. See, b is 3. So have you seen we found the value of A, B, and C? This method is it's very simple, isn't it? Are we together? You found the value of A, B, and C. So where there is A, put the value of A. Where you had A, put the value of A. So look at this. A is here, meaning where there is A, you put the value of A, which we found to be 1, isn't it? Where there is B, you put the value of B, which we found to be 3, isn't it? Where there is C, you put the value of C, which we found to be negative 2. Are you seeing that? Are we together? So it means you've resolved it into partial fraction with a much more simpler method, isn't it? With a much more simpler method. Now, what you can do is to confirm whether you have the right answers, isn't it? But you don't do that because we know we've confirmed we had the right answers, isn't it? X squared plus 3 and x plus 9. See this times this. See, that is x squared plus 9. Then it is plus this times this, isn't it? See, that is 3x minus 2 into x plus 3. Are we together? So what is this? So it is x squared plus 9 for this term plus you factorize this, isn't it? I have 3x times x, so 3x squared. 3x times 3, so it is plus 9x. Minus 2 times x, see minus 2x. Minus 2 times plus 3, see minus 6. So can you start simplifying? X squared plus 3x squared, remember the whole of this is over x plus 3 and x squared plus 9. So start x squared and plus 3x squared, so you get your 4x squared. Are you seeing that? Then plus 9x minus 2x, you get plus 7x. Are you seeing that? Then plus 9 and minus 6, you get positive 3. So you see that method is much more simpler. Are we together? Yes. Good. So, once you resolve that, what do? Our integrals were there, meaning we put integral on everything, isn't it? Integral on everything, then with respect to x, with respect to x, with respect to x. So you see, what is here is what you had there has been resolved into partial fractions. So you see, so you are doing integration by partial fractions. Now, look at this. Now, what I want you to look is this. Remember, our limits we'll put later. We'll put them later, but you know they are from 0 to 1, but we'll put them later after the integration, isn't it? Now, something here I want you to see. Look at this term. Look at this term. This term, 3x minus 2 over x squared plus 9. Remember, if you let u to be x squared plus 9, if you differentiate u with respect to x, you will get 2x, isn't it? So if you see 2x, meaning if you take dx the other side, you remain with the u is equals to 2x dx. You can see 2x dx is not what is in the numerator. Are we together? It is not what is in the... So that means, when it is not what is in the numerator, then it means you have to separate this. Are we together? And this is how you separate. What is in the numerator is a common denominator. So it means the first part will be 3x over x squared plus 9. Then it is minus 2 over x squared plus 9. Because x squared plus 9 is there. It's the common denominator. Are you seeing how to do it? Because you know when you use the u, you are not going to get what's in the meaning you are not going to integrate it. Are you seeing that? So you have to separate it. 3x over x squared plus 9, then minus 2 over x squared plus 9. Have you got that? Good. So can you now separate that? So if you separate it, what are you going to get? The first one remains the way it is, isn't it? Integration from then dx over x plus 3, that is this, isn't it? Then the next one is plus, you are integrating from 0 to 1, then 3x over x squared plus 9, isn't it? Then the next one is minus 2 over, are we together? From 0 to 1, then negative 2 over x squared plus 9. And remember everything with respect to x, isn't it? Are you seeing you separated it? Your 3x, you place it on your own, and your negative 2, you place it on your own. They are sharing the same denominator. Is that okay? You have separated them because they are resulting in different functions, isn't it? You will find some is inverse function, the other one is logarithmic, isn't it? Are we together? Good. So from here, what do? Can somebody suggest what you do? What you do is that you factorize out the constants, isn't it? You factorize out the constant, meaning these steps, I'm only using them from explanation, but there are steps you will just ignore at the first point there, isn't it? I'm only putting them for a explanation. So here, see 3 is a constant, you factorize outside. So you have plus 3 into 0 to 1 x dx over x squared plus 9, isn't it? See here, negative 2 is a constant. See, this was plus. When I placed minus, meaning here we're supposed to remain with the 2, isn't it? Isn't it? Are we together? Because the sign which was says plus. Negative 2 is still inside. So it's when we now remove negative 2 outside, isn't it? Are we together? Yes. So if you placed here negative, it means you left 2 in. So that negative into 2, you get back your negative 2. Are you seeing that? Is that okay? Yeah. So when you bring back your 2 outside, you have your negative 2 into the integral from 0 to that dx over x squared plus 9. Are you seeing you factorize out those constants? Yeah. The constant you add here 3, you've removed it outside. The constant you add here negative 2, you've removed it outside. Have you seen that? Is that okay? Good. So the next thing you do is now to integrate each and every part, isn't it? We are now want to integrate. So start. If you integrate dx over x, what do you get? Over x plus 3. That is ln of x plus 3. Because here you simply let u to be x plus 3, isn't it? So it means if you differentiate u with respect to x, you get the u is supposed to be x. Because differentiating x 1, differentiating 3 0. A constant, isn't it? Are we together? So in this, when you now have dx over x plus 3, where there is dx, you put du, your x plus 3 was u. So du over u is ln of u. And your u is x plus 3. So ln of u is ln of x plus 3, because x plus 3 is the u. Are we together? That is standard integration. Standard integration is just to be written the way I've written it, isn't it? Are we together? You move to the next one, we have here plus 3. Then check at this. This is still logarithmic, isn't it? See, that is logarithmic. Can somebody tell me the answer there? You let x squared plus 9 to be u, isn't it? Because we see the function denominator is 1, is degree of 1 and x2. So we said when the degree of a polynomial denominator is 1 less than the one in the denominator, then it will result in logarithmic. Are we together? Yeah, so it means when you let u to be x squared plus 9, are you seeing that? Look here. When you let u to be x squared plus 9, what is the denominator? When you differentiate u with respect to x, you get du over dx to be equals to differentiating x squared, you get 2. Differentiating a constant, you get 0, isn't it? So if you multiply both sides by dx, you remain with the du is equals to 2x dx, isn't it? So do you see what do? You multiply the numerator by 2 and you divide by 2. Are you seeing that? So that your 2x dx is du. Are you seeing that? Then your x squared plus 9 is u. Are you seeing that? So what do we have there? Meaning if you have the integral of 2x dx over x squared plus 9, 2x dx we found is du. Over x squared plus 9 we found is u. Are you seeing that? So du over u, integrating du over u is ln of u. See there? And what is your u? Meaning what we are getting here is ln of u, but our u is x squared plus 9. Are you seeing that is standard integration? It's just something you write there like that. You see I'm using a different color because that is rough work, isn't it? Are we together? Go on. Yes.
Is it 3 over 2 ln of x?
Oh, where is our 2? Sorry. Our it is 3 over 2 ln of that, isn't it? Very good. That is very good. Yeah. Move on. Here, can somebody now tell me the answer there? Huh? Now, this one looks tricky. Do you know why it looks tricky? Because if you look at it, it is this. It is the integral of dx over 1 plus a squared x squared, isn't it? See, that is the form it is in. The tan inverse, isn't it? Meaning what you are supposed here to get is 1 over a tan inverse of ax. See, that is what it's supposed to result into. Are you saying it is that? Because this is x squared plus 9, meaning it is 9 plus x squared. Tuko pamoja? So what do you do there? The first thing you do is that this 9 must come outside, isn't it? So when this 9 is coming outside, if you bring this 9 outside, if you bring this 9 outside here, what do? What will you get? Like this. This is what it will be. When you have x squared plus 9, if you want to remove 9 outside, meaning if this 9 is outside here, when this 9 is outside here, you must divide everything inside by 9. Are you seeing that? You must divide everything inside by 9, so that when you take back 9 inside, you get back your x squared plus 9 the way it was, isn't it? So you see, we've removed 9 outside, it is like this. Remember, 9 is here. So it is like 1 over 9. Are you seeing? So 2 times 1 over 9, see, you will factor this outside as 2 over 9. Are you seeing that? Then you remain with, what do you remain with inside? X squared over 9. 9 over 9 is 1. Now look at this. Dx over x squared over 9. Remember, x squared over 9. 9 it means it is 1 over 3 squared. See, that is 1 over 9. 1 over 3 squared x squared plus 1. See, that is what it is. Are you seeing that? So what is your a? A is 1 over 3. Because it is a squared, x squared, the tan inverse. So this one is in the form because x squared over 9 means it is, or you can write it as x over 3 squared plus 1. Because everything is now squared. 3 squared goes back to 9, isn't it? So this one is in the form dx over 1 plus a squared x squared. Senor? So it means a squared x squared, here you can see 1 over 3x. So it means you are a squared x squared. So a is 1 over 3. Because this derivative, you are supposed to get 1 over a tan inverse of ax. Have you seen that? So what is your a? Your a is 1 over 3. So where there is a, you put 1 over 3. Where there is a, you put 1 over 3. So 1 divided by 1 over 3, see, you get it is 3. See, 1 divided by 1 over 3 is 3. So it means the derivative of the whole of this problem is 3 tan inverse of a third x. Have you seen how that standard integration as what? And what do we have outside here? Negative 2 over 9, isn't it? So we have negative 2 over 9, then inside we have 3 tan inverse of a third x. We have 3 tan inverse of a third x. So this is, you've integrated everything. Are we together? Yes. So after integrating everything, you put your limits of integration, which is from 0 to 1. Okay? So when you substitute the limits, you will be able to get the answer. This is what you need to do. It is x ln of x plus 3 plus 3 over 2 ln of x squared plus 9, then minus 2 over 9 times 3, you get? So you get 2 over 3 if you simplify. 2 over 3 tan inverse of a third x. Then your limits are from 0 to 1. So what you will do is this. Where there is x, you put 1 to form your upper limit. Are you seeing that? When you put 1 here, you will get ln of 4 plus 3 over 2. 1 squared is 1. ln of 10, isn't it? Are you seeing that? Then minus 2 over 3 tan inverse of a third, because x is 1. So you substituted the upper limit. Then you substitute the lower limit minus. You put the bracket for the lower limit 0. Are you seeing that? Are we together? When x is 0, when there's x, you put 0, you remain with ln of 3, because 0 plus 3 is 3, isn't it? ln of 3 plus 3 over 2, ln of ln of 9, because x0 squared you remain with 9, isn't it? Ln of 9 minus 2 over 3 tan inverse of 0. So have you seen you now have upper limit minus lower limit? Are we together? Then finally you write the answer. And you are done. Is that okay? Okay? Good. So if you substitute those values, what do you get? Remember, when you are looking for those tan inverse, the answer, the calculator must be in pi radians, not degrees, because all these are pi radians. So you cannot use calculator in a D. The calculator must be in R. Ln of 4 will be given in pi radians, ln, these are pi radians. So tan inverse of this, you should not get it in degrees. It's like you will be mixing pi radians with degrees and you are getting an irrelevant thing. Are you seeing that? It's like you're saying 10 meter plus 10 centimeter is 20 centimeter meter. Such kind of things. If everything is pi radian, it's pi radians. This one is not degrees, this one is not degrees, so this one cannot be degrees. Are you getting that? Are we together? So it must be pi radians. So what have you found? You set the number at R. I don't like that calculator. So find the answer of that and you write it there.